US Physics Olympiad 2008 Semifinal. That semifinal consisted from 3 stages. The first stage, part A, had 4 problems. For these 4 problems there were 60 minutes. Stage 2, that was part B, there were 2 problems, and for 2 problems they had 60 minutes. And stage 3, which is part C, it was from 1 question, 1 problem. That was 20 minutes for this problem. Part A, question A1. 4 square metal plates of area big A are arranged at an even space D as shown in the diagram. Assume that A much greater than D square. Plates 1 and 4 are first connected to a voltage source of magnitude V0, with the plate 1 positive. Plates 2 and 3 are then connected together with a wire. The wire is subsequently removed. Finally, the voltage source attached between plates 1 and 4 is replaced with a wire. The steps are summarized in the diagrams. Find the resulting potential difference V12 between plates 1 and 2. Likewise, find V23 and V34 defined similarly. Assume in each case that a positive potential difference means that the top plate is at a higher potential than a bottom plate. Solution. This problem could be solved using different approaches. One approach is to represent this figure as 3 capacitors, equal capacitors connected in series, like between these plates, and these plates. But here we will use other approach. We will use electric field between plates. So first of all, we have this thing that potential difference between first and last plate is V0, and because third and second plate are connected, potential difference between them is 0. It means that the electric field between them is 0. Remaining is electric field between the first and second plate and between third and fourth plate. Due to absolute symmetry, this electric field will be equal, and we can show it on the picture. So we have this diagram that here we have electric field E0, and here we have electric field E0. So now we can find what is this electric field. We have this equation. We multiply electric field by distance, that's 2d, and that will be voltage V0. This is how to find E0. Now let's move further. We can replace this picture by other picture, and showing how is how are charges distributed between plates. We have charge sigma 1 on the first plate, and due to symmetry, negative charge negative sigma 1 on the last plate. And because these charges they compensate each other between the second and third plate, this charge must have density negative sigma 1, and this charge is positive sigma 1. And this charge sigma 1 and negative sigma 1, they create electric field E0. And for same reason, this charge and this charge, they create between them electric field negative E0. Now let's write the last picture when we connect first and last plates. So this is the picture. Now we know that charge negative sigma 1 and sigma 1 create electric field negative E0. It means that we can write that E2 created by these plates, second and third, it's negative E0. And the plates first and last one, they create between them electric field E1. We don't know yet what it is, but we can calculate what is total potential difference created by all plates. That will be 0, because this and this connected, but from other hand we have this equation. Potential difference between first and last one, that will be 3E1 multiplied by D plus E2 multiplied by D, and that's equal 0. And we know that E2 equal negative E0, and from here we can find that electric field E1 equal E0 over 3, or due to this it's equal voltage V0 over 6D. And now we can immediately find what is a potential difference between first and second plate. That will be this one. So we have V12 equal V0 over 6, and due to symmetry it's the same as for V34 between third and fourth plates. And last step is to count what is potential difference between plate 2 and 3. To make this total potential difference 0, it must be equal negative V0 over 3. So that's the answer. Between first and second plates we have potential difference V0 over 6, same as between number 3 and number 4. And potential difference between second and third, that will be negative V0 over 3.